Our white paper is focused on the insufficient system performance as a result of dataset insufficiencies. Mentioned a couple of times already, data is becoming the crucial part of everything. And since data plays that major role in AI training and testing, similar insufficiency in test and the validation data can produce basically a systematic fault, which will pass under the radar. You'll not see it. And those insufficiencies can go from all the way specification level to the performance level. Like more specifically, if you talk about vehicle level function specification, basically it's not translated in a good way to the data specification. And that can give, as a result, an AI model which has insufficient performance or even completely lacking performance with respect, I don't know, for example, some specific type of object class or similar. You just miss that type of object because you didn't define data set requirements and everything going with it in a good way. And the paper describes this in a nice way, using concrete examples from public data set, how data set lifecycle looks like, and what are particular properties which data should satisfy from safety perspective, of course, ensuring that safety-related properties like relevance, completeness, balance, correctness of labels or annotations, traceability, etc., are present right from the start of the product development. And that can save a lot of pain and working hours later in the development. One interesting example is the choice of hardware. Like when you think about data collection as an extremely important and super expensive step in the development, one can imagine that organizations can have tendency to cut the cost somewhere, right? And this could be one of the tempting places to do savings while choosing the hardware. So it's obvious, since if you don't want to collect more data, so if you want to collect more data with different hardware, you need to buy more equipment, right? And build more cars, probably drive around more overall, and ensure support for various types of hardware, etc. However, going further, that diversity in data set later in the development will likely pay off by providing more robust AI models, and investment will likely pay off by having less reported insufficiencies and more safe system on the road. And this paper also gives some practical advices about metadata tags and how to make use of it, as well as labels and labeling process, and how important it is for the entire AI model and therefore entire system development. I don't know, Ivan, do you think I missed something? I try to kind of summarize it
Yeah, I
briefly.
think you covered it quite well. So the sources where we get at all of the information there was, for one, the ISO standards, but we also referenced the AMLAS and CODAN
Yeah, true.
papers, yeah, which might be of interest to the listeners. So I don't know if you are familiar with it or not. So basically, those are um, papers or other publications that were well issued before the ISO 8800 became official. They were attempts to standardize, rather to introduce a process of how to formalize the life cycle for um, um, machine learning in autonomous systems. So the AMLAS was published by the University of New York, and I believe CODAN was by the European Aviation Agency or something. And so the gist in them is they both focus on the safety argumentation through the life cycle. So again, as Gokul mentioned before, since the ISO 8800 itself also doesn't say where is enough validation. The same way in these standards, they are also not putting a definitive limit. This sufficient validation, but instead introduce several steps within the life cycle of the model through which, if we provide the argumentation, we prove that we did our due diligence to make the model safe and to consider potential unknown risks. And in our work, in our white paper, a lot of conclusions basically converged into similar conclusions from all of the three works. So, for example, we have references on dataset properties, which in the end quite correspond to each other or are, let's say, mappable. Then the requirements definition and the process how the data requirements need to be defined again converges on similar conclusions. But it's still interesting to see how this was done, as I said before, the ISO standard was officially introduced.